In this video, we're going to use the definition of constant velocity to come up with a relationship to determine how long it takes for an object traveling at constant velocity to move a certain distance. That is, we're going to algebraically rearrange this equation to come up with a relationship to find the time it takes for an object to travel a given distance at a given velocity. So suppose you have an object moving at a constant velocity of 2 meters per second. And let's say we measure the distance over which this object is traveling, and let's say this object moves a distance of exactly 10 meters. And we want to know how long it takes for that object to travel that 10 meters. So what I want to do is show you how we get this relationship. And the thing that you shouldn't do is memorize this relationship. You should learn the steps it takes to get from this definition of constant velocity to this relationship to find the time it takes for an object to travel a given distance at a given velocity. So to begin, let's start with our definition of constant velocity. So constant velocity says you move a given distance in a given period of time. Now in this case, we know our velocity, we know the distance this object travels, and we want to know the time it takes for this object to travel this distance. So the first thing we're going to do is we're going to multiply both sides of this equation by time. What you do to one side of an equation, you have to do to the other side. And now what you should see is that this unit of time cancels out with this unit of time, and we can rewrite the left-hand side of this equation as velocity times time equals the distance. Now we know our velocity, we know the distance this object travels, and what we're looking for is the time it takes for this object to travel this distance at this velocity. So the next thing you need to do is you need to divide both sides of this equation by velocity. What you do to one side of an equation, you do to the other side. So what you should see is that this unit of velocity cancels out with this unit of velocity, and you can now rewrite the left-hand side of this equation as time equals the distance this object travels divided by the velocity the object's traveling at. And this is the exact formula that we started with. Now in this problem, we said the object traveled a distance of 10 meters, and we said that the velocity that this object was traveling at was exactly 2 meters per second. Now you can rewrite this fraction as 10 divided by 2, that's the number, times a meter divided by a meter per second. And now we can simplify this expression. You know that 10 divided by 2 is equal to the number 5. This unit of a meter divided by a meter per second works out to be a unit of time, a unit of seconds. Now I just want to show you one more way to simplify this unit, because this is an improper fraction. So to come up with this unit of a second from a meter divided by a meter per second, you basically take a meter divided by a meter per second. This is an improper fraction, so what you need to do is you need to multiply this number here in the denominator by its reciprocal. But you can't just do that. What you do to the bottom, you have to do to the top. And the next thing is to cancel out like terms. So this unit of second cancels out with this unit of second, this unit of meter cancels out with this unit of meter, and then this meter cancels out with this meter, and you get a unit of a second. Now there's two more ways I want to approach this problem. Let's suppose you start with the object's velocity equals distance over time. Now we know the velocity, we know the distance, so let's just start by plugging those values in. So in this case, the velocity was 2 meters per second, and that's going to equal the distance, which is 10 meters, over our unknown, in this case, time. And so what this works out to be is another algebra problem. So to solve for time, what we need to do is we need to multiply both sides of the equation by time. What you do to one side of an equation, you do to the other. This unit of time cancels out with this unit of time. And then on the left-hand side, you get the time times 2 meters per second, which is the velocity. And that's going to equal the distance this object travels, which is 10 meters. Now the next step to do is to solve for time. In this case, we're going to divide both sides by 2 meters per second. What you do to one side of an equation, you do to the other. And when you do that, 2 meters per second divided by 2 meters per second is equal to 1. And this works out to be t equals 10 meters divided by 2 meters per second. And that's going to work out to be 5 seconds. Now one last way I'm going to show you to solve this is to relate it back to a problem that you may have encountered in an algebra class. And we're again going to start with velocity equals distance over time. And in this case, what we're going to do is we're going to just drop the units to make this problem a little bit more easy to understand. So we know that our velocity is equal to 2 meters per second, and we're going to set that equal to 10 meters, and again I'm omitting the units, divided by our unknown, in this case the unit of time. Now this number 2 is really the number 2 over 1. Any number divided by the number 1 is the number itself, in this case 2. Now this is our unknown, this is the number that we're trying to solve for. So what you should know from an algebra class is when you have two fractions equal to each other, you can cross multiply, and when you do that, the left-hand side becomes 2 times t, and that's going to equal 10 times the number 1. 10 times 1 is just 10. And now the next step to do is to solve for t. So what you should do is divide both sides by 2. And when you do that, 2 divided by 2 is 1. And then you get t equals 10 divided by 2, which equals 5.